Hello everyone, I am Double Angrez. I welcome you to my YouTube channel and let's start a new video. Now I will explain two-dimensional array. Generally, two-dimensional arrays are used to store table of same type values, means rows and columns format. So there are two indices are used in two-dimensional array. One is used to point the number of row and another is used to point the number of column. In mathematics, we are familiar with matrices. To access an element, we are using syntax Aij that represent the value of ith row and jth column of a matrix A. In C, matrix A can be represented by a two-dimensional array A, and A of ij is used to represent the value of ith row and jth column of that array. Here is an example. This is how we are writing matrix in mathematics. This can be represented in C. To represent the value 325 in maths, we use symbol A 2 3 to represent the number of row, that means second row, and 3 represent the number of column, that means third column, which is pointing to the value 325. The same can be represented in C like A of 1 2. 1 means second row and 2 means third column, because in C index starts from 0. So A of 1 2 will represent the same value 325. To declare two-dimension array, there is a syntax data type space array name space in first square bracket row size, in second square bracket column size, and then semicolon. If number of rows are 3, then row size will be 2 because array index starts from 0. Similar for column size. Here is an example. If we want to declare a matrix of size 4 cross 3, then we can declare in C like this: integer A of 3 2, and we can put the values like this. So it will also utilize 12 continuous memory locations. In memory location, the values are stored row wise. So on first memory location, this value will be stored, and then on second memory location, this 275 will be stored. On third memory location, this 365 will be stored. After this 365, the next row will be stored. That means 210 will be stored on fourth memory location, and then on fifth memory location, this 190 will be stored. This is how a two-dimensional array is stored in the memory in continuous form. It is always stored in row-wise manner. For initialization, there are two types again: compile time initialization and runtime initialization. Compile time initialization, here are some examples. Most common initialization form is first one, integer matrix 2 3 is equal to 0 0 0 1 1 1 separated by comma. It will initialize first row with 0 and second row with 1. If you want to generalize this form, then you can specify the values row wise in separated by comma. If you want to specify the values in form of matrix, then you can write like this. It is not always required to specify the first dimension of two-dimensional matrix. Okay, so you can skip the first dimension. It will be automatically taken as per the values given at compile time. If there are some missing values in the compile time initialization, then they are initialized with 0 in case of numerics and a symbolic constant null in case of characters. There are more generalized forms to initialize two-dimensional array at compile time. Another type of initialization is runtime initialization. For runtime initialization, generally nested loops are used, and this is simple code snippet which shows the runtime initialization of two-dimensional matrix. You can directly assign the values, or you can ask values to user by using scanf in nested loops. Now the practical time. We'll write a C program to perform matrix operations. Now we will perform some matrix operations. I will implement matrix multiplication. For that I will need two matrices. So I will need some variables to store the size of these two matrices. Like first matrix will be m cross n, so I will declare m and n. Second matrix will be of size p cross q, so I will declare pq. These four variables are used to store the size of these two matrices. Then I will declare matrices A of size max, that is symbolic constant, initialized with 10. Similarly, another matrix will be B of same size, and result will be stored in C. This A, B and C are three two-dimensional arrays which are used to represent the matrices A, B and C. First of all, I will ask the user to enter the dimension of first matrix. Then I will do same for second matrix. Then I will check the condition whether the number of column of first matrix is equal to the number of row of second matrix. Means if n is double equal to p, then only we can perform the matrix multiplication. Else I will display error that entered dimensions are incorrect. If both dimensions are matching, then I will scan the matrices by using nested loops. For that I will require two loop control variables I and j. First of all, I will scan the first matrix. Enter matrix A for I is equal to 0, I less than m, that is the row size of matrix A, and I plus plus. Then nested loop will be for j is equal to 0, j is less than n, and j plus plus, where n is the column size of matrix A. And over here we will scan the elements from terminal using scanf function. Scanf %d and a of I j. This is how matrix A will be scanned. Similar code I will write for matrix B. Printf, enter matrix B in next line for I is equal to 0, I is less than B, which is the row size of matrix B, and I plus plus. In inner loop for j is equal to 0, j is less than q, which is the column size of matrix B, and j plus plus. In inner loop I will scan the elements of matrix B. %d and B of I j. This is how matrix B will be scanned. Now we will perform the matrix multiplication. For this I will require 3 loops. Outer loop will be for I is equal to 0, I is less than m. Remember, the resultant matrix will be of size m cross q. M is the row size of matrix A and q is the row size of matrix B. So I less than m and I plus plus. In inner loop for j is equal to 0, j less than q, and j plus plus. Q is the column size of matrix B. Over here I will initialize the C of ij is equal to 0. So for addition we will run third loop for k is equal to 0, k is less than n. Well, over here n must equal to p. So we can say that n is the column size of matrix A, which is equal to row size of matrix B. So K is less than N. You can also write K is less than P. So for K is equal to 0, K less than N, and K plus plus. Inside this loop, I will write the equation to find C of ij. C of ij is equal to C of ij plus A of ik multiplied by B of kj. This is the equation to find the C of ij. So this is how the matrix multiplication will be done. Now I will print the resultant matrix C. So printf result of matrix multiplication in next line. To print the matrix, I will require another two loops. For I is equal to 0, I is less than n, row size of resultant matrix, and I plus plus. Inner loop for j is equal to 0, j is less than q, column size of matrix C, that is resultant matrix, and j plus plus. Over here I can simply print %d with space for %d C of I j. So this will print the elements of resultant matrix separated by space, and to separate the column I will print a new line character outside the inner loop. So this will print the resultant matrix. Now let's check this program. Success. Run this program. First of all, I will enter the dimension of matrix A, 3 cross 3. Similarly, for matrix B, it is also 3 cross 3 matrix. Now elements of matrix A. I will enter the elements in matrix form, like 1 space 3. So this is matrix A. Now I will enter the elements of matrix B. So you can see the answer of matrix multiplication. This is how we can perform other matrix operations like matrix addition, then matrix subtraction, and transpose of matrix. Another type of array is multidimensional array. If there are 3 or more dimensions, then multidimensional arrays are used. This kind of arrays are used to store more than one tables. Declaration syntax: data type space array name. Then if there are m dimensions, then you can write like this: in first square bracket s1, second square brackets s2, up to in last square brackets sn. For example, there is an integer multidimensional array int survey, first dimension size 3, second dimension size 5, and third dimension size 12. This is 3-dimensional array. In example we can take a survey like this kind of array can store the rainfall details of 12 months, 5 cities and 3 years. This is how multidimensional arrays are used. Another 4-dimensional array example is float. Array name is table, then list of 4 dimension size. Another type of array is dynamic arrays. Generally, there are two types of memory allocations in C, static memory allocation and dynamic memory allocation. Till now, we have studied about static memory allocation means we are declaring the size at compile time. If you want to declare the size at runtime, then dynamic memory allocation is used. So to create dynamic arrays, dynamic memory allocations is used. Dynamic arrays are created at runtime using pointer variables and memory management functions like malloc, calloc, and realloc. Generally, dynamic arrays are used to create and manipulate the data structures like linked list, stacks, and queues. So this is all about arrays. If you like this video, then please press the like button, and if you want to get more videos like this, then please subscribe my channel. Okay, goodbye, take care, see you in next video.